Hello dear student, welcome to new session of current electricity. It's your 10th class. In previous class we'll discuss about combination of batteries, and I already tell you that batteries are combined in two different methods, or we can say batteries are combined in two different segments. One is series combination and other is parallel combination, and we'll discuss already about series combination of battery. The first very important thing that must be present in your mind, that why we are combining the batteries. We are combining the batteries to increase the potential of the circuit, to increase the potential of the circuit. That's why I'm combining batteries. So in series combination, what we'll see the net EMF is increasing and it is equals to E1 plus E2 plus E3, but along with net EMF, internal resistance is also increasing. So if internal resistance of circuit increases, then current is not increased, because if resistance increases, then current, my dear student, is decreases. So we can say that in series combination, if batteries are connected, then EMF is increased, but along with EMF, internal resistance also increase. Then we'll go for parallel combination of batteries. So write down next heading, it is parallel combination of batteries. Write down parallel combination of batteries. Our next topic is parallel combination of batteries. Parallel combination of batteries. So write down, consider three batteries. Write down, I am dictating. Consider three batteries of EMF E1, E2 and E3. Consider three batteries of EMF E1, E2 and E3 having internal resistance R1, R2 and R3, having internal resistance R1, R2 and R3, having internal resistance R1, R2 and R3 is connected with an external resistor, is connected with an external resistor of resistance, is connected with an external resistor of resistance capital R, of resistance capital R. So this is nothing but parallel combination. See my dear student, here we have three batteries, first, second and third. All the batteries are connected parallel to each other. Here the potential of first battery is E1, internal resistance is R1, second battery EMF is E2, as we know that now that potential of the terminal is nothing but also called EMF. So instead potential you can also say it's EMF. So second battery EMF is E2, internal resistance is R2, third battery EMF is E3 and internal resistance is R3. These all batteries are connected with this external resistor of resistance, dear student, capital R. Now see, we know that the external resistor draw current from the battery. So let's suppose first battery gives some I1 current, second battery gives some I2 current and third battery gives some I3 current. Now this I1 moves forward, I2 moves forward and I3 moves forward. Now from here the current get only one path, so all the current combined and this external resistor is getting I current, that is I must be equal to I1 plus I2 plus I3, because This I is I1, I2 and I3 combined to form, dear student, I. Now again, this battery gives I2 current, so we'll give back I2 current. This battery gives I1, so we'll give back I1 current. This battery gives I3 current, so we'll give I3 current back to this battery. So we have three batteries. In first battery, I1 current is there. In second battery, I2 current is there. And in third battery, I3 current is there. And we know I must be equal to I1 plus I2 plus I3. So this is basically the system what we'll discuss. Now my dear student, we have to apply Kirchhoff's second law to find current, because we know that with the help of Kirchhoff's second law, we'll get the equation of current. So by applying Kirchhoff's first law, second law, before applying Kirchhoff's second law, I am writing the path A, B, C, and this is D, this is E, this is F, G, H and I. I am making equation of first battery first, then second battery and then third battery, similar to what we'll perform in combination of resistor. So for first battery, I am applying Kirchhoff's voltage law, which is also called, dear student, second law. So I am applying Kirchhoff's second law for first battery. So the loop is A, B, C, D, E, I, H and again A, B, C, D, E and again I, then H and then again A. So I am moving like this, clockwise. So like this. So I am moving like this. I'll counter with battery whose positive potential is there. I am moving from positive to negative, means from high to low. So my potential is decreasing. So I'll write minus E1. Now see, the direction of current and my current is opposite. So I'll write, my dear student, if moving same direction, then we can write plus IR. Moving moving same direction, we can write minus IR. Moving opposite direction to current, we can write plus IR. So here comes, we'll write plus I1 R1. Then moving forward, external resistor, my direction and current direction is opposite. Again I'll write plus IR is equals to 0. So from here what we'll get, E1 considered to be in this side. So I1 R1 plus IR is equals to E1. This is our equation number first. Moving forward, my dear student, I am writing KVL for second battery. So for second battery, my dear student, the loop must be A, B, E, I, H and again A, B, E, I, H and again A. So I am moving like this. So plus to minus, we can write minus E2. My direction and current direction is opposite. So I'll write plus I2 R2. Now moving, my direction and current direction, again it is opposite. So I'll write plus IR and it is equals to 0. Take negative this side. So I2 R2 plus IR is equals to, dear student, E2. So this is our equation number second. Moving forward, I am writing KVL for, or we can say second law for third battery. So I'll write for third battery. What it is? Loop is A, B, G, F. So A, B, G, F, then again E, then I, then H and then again A. Again plus to minus means I am going from higher potential to lower potential. So my potential is decreasing. So we'll use minus. So minus E3, my direction and current direction, again it is opposite. So I'll write plus I3 R3, then opposite. So I'll write plus IR and it is equals to 0. Take negative this side. So I3 R3 plus IR is equals to E3. This is our equation number third. So now see, my dear student, in this we know that I becomes equals to, I is equals to I1 plus I2 plus I3. So just I am trying to get the value of I1, I2 and I3, so that we'll add all the equation and we'll put the value here, so that we'll get the value of I. Now see, in first equation, along with I1, R1 is there. In second equation, along with I2, R2 is there, and in third equation, along with I3, R3 is there. So what we are doing now, we have to divide this equation with R1 so that this I1 get free. Divide this equation by R2 so that I2 get free. Divide this equation with R3 so that I3 get free. So from equation first, divide LHS and RHS by small r1, dear students. So what we'll get? We'll get I1 R1 divided by R1 plus IR divided by R1 is equals to E1 by R1. Now see, R1 get cancelled. So we'll get I1 plus IR by R1 is equals to E1 by R1. This is now our next equation. Let's suppose it is A. Similarly, if I am dividing equation 2 by R2, what we'll get? Just check it out. I am dividing second equation by R2 so that I2 get free. So divide equation 2 by R2. So what we'll get? I2 R2 divided by R2 plus IR divided by R2 is equals to E2 by R2. Now see, R2 get cancelled. So we'll get I2 plus IR by R2 is equals to E2 by R2. This is our equation. Let's suppose it is B. Now moving forward, look at equation 3. So now I'll divide equation 3 by R3. So divide equation 3 by R3. What we'll get, dear student? We'll get the third equation is I3 R3 divided by R3 plus IR divided by R3 is equals to E3 by R3. Now see, R3 get cancelled. So I3 plus IR by R3 is equals to E3 by R3. This is our equation number C. So we'll get equation A as I1 plus IR by R1 is equals to E1 by R1. Equation B as I2 plus IR by R2 is equals to E2 by R2. And equation third as C as I3 plus IR by R3 is equals to E3 by R3. Now as we know, if we'll add I1, I2 and I3, what we'll get, dear student? We'll get I. So see, I'm adding A, B and C. So I'm writing add equation A, B and C. So what we'll get? Just check it out. I'm adding equation A, B and C. I'm writing here add equation A, B and C. So what we'll get? I1 plus I2 plus I3. It is equals to I. So I'll write here directly I plus IR by R1 plus IR by R2 plus IR by R3 is equals to E1 by R1 plus E2 by R2 plus E3 by R3. Now see, I am taking common I from here. So I taking common, and what we'll get? We'll get before this, let's I plus IR getting common. So what we'll get? 1 by R1 plus 1 by R2 plus 1 by R3 is equals to E1 by R1 plus E2 by R2 plus E3 by R3, dear student. Now see, from here I'll take I common. So what we'll get? 1 plus R, 1 by R1 plus 1 by R2 plus 1 by R3 is equals to E1 by R1 plus E2 by R2 plus E3 by R3. Now we'll get the value of I as, take all the terms denominated to E1 by R1 plus E2 by R2 plus E3 by R3. From here we'll get I. So I becomes equals to E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 plus R, 1 by R1 plus 1 by R2 plus 1 by R3. This is the value of, dear student, current which is given by all the three batteries to the external resistor capital R. I hope you all understand this thing. So I becomes equals to E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 plus R, 1 by R1 plus 1 by R2 plus 1 by R3. Now what we'll do, see, all three batteries can combine and give I current to this external resistor. Now what we have to do, we'll replace all the three batteries with a single battery. I'm repeating once again, dear student. See, the process is same as what we'll perform in combination of resistor, what we'll perform in series combination of battery itself. So now we are replacing all the three batteries with a single battery which give same amount of current to this external resistor capital R. So if you are replacing all the three batteries with a single battery which give same amount of current to the external resistor, it means that battery EMF must be equal to combination of all the battery, and that battery internal resistance must be equal to combination of all the resistor. I am repeating once again, what we have to do now, we'll replace all the batteries with a single battery. I am writing here, replace all the batteries with a single battery. Write down, replace all the battery with a single battery. Replace all the battery with a single battery, which gives same current to the external resistor capital R. So see, my dear student, I am replacing all the three batteries with a single battery which give same current to the external resistor whose resistance is capital R. So this is what we have. The battery potential is E net, internal resistance is R net, and external resistor is capital R. Now see, this battery is replaced by all the three batteries. So its EMF must be equal to all the three batteries, and internal resistance is also equals to sum of all the three batteries. Now see what we'll say. We'll say this battery can give same amount of current to the external resistor. So all the batteries can combine and give I current to the external resistor. Now this battery is giving I current to the external resistor. That this current and this current is same because we are replacing instead of all the three batteries. So I current is given by this battery to the external resistor capital R. Now see, my dear student, this is also a closed circuit. So if this is a closed circuit, then we are capable to apply Kirchhoff's voltage law again. So write down, by Kirchhoff's voltage law. So I am writing here, by Kirchhoff's voltage law. What we'll get? Check it out. By Kirchhoff's voltage law. So see, my dear student, I am moving like this, closed loop, in closed loop by KVL. So see, I am moving from plus to minus, higher to lower, means minus E net. My direction and current direction is opposite. So plus IR net. Again, my direction and current direction is opposite in external resistor. So plus IR is equals to 0. Now negative take this side. So what we'll get? IR net plus IR is equals to, dear student, E net. Now taking common I. So if I takes common, it is R net plus R is equals to E net. So what we'll get? We'll get I is equals to E net by R net plus R. Now see, my dear student, this equation, let's suppose this equation is beta, and let's suppose this equation is alpha. Now see, the current in beta and current is alpha. is same, because what we'll say replace all the 3 batteries with a single battery which draw same current, which gives same current to the external resistor. So now this current and this current is same. So after, if this current and this current is same, so we'll compare this equation and this equation. But here, my dear student, we cannot compare alpha and beta directly, because see, in this alpha we have, along with R, we have this big term, that is 1 by R1 plus 1 by R2 plus 1 by R3. So in this equation, along with R, the big term is there. There is one more term which is present. It is 1 by R1 plus 1 by R2 plus 1 by R3. But if you're seeing this equation, along with R, nothing is there. So my dear student, comparison is always taken, or we can say comparison is always done with similar terms. So this term and this term is not similar, as in this term along with R we have 1 by R1 plus 1 by R2 plus 1 by R3, but in this R nothing is there. So we can say either we have to add 1 by R1 plus 1 by R2 plus 1 by R3 along with this R, or remove 1 by R1 plus 1 by R2 plus 1 by R3 with this term, so that we'll compare both the equation. If we'll add or remove this term from this equation or add this equation in this term, then only we can perform comparison. Because remember, my dear student, comparison is always performed with 2 similar terms. So here this current and this current is not similar terms. So what we have to do, we have to now process to remove this term along, which is present along with this capital R. So I am writing here, from equation alpha. From equation alpha, I hope you all are understanding these terms. My dear student, this is a very basic thing which we already performed in maths lots of time. So now what we have to do, we have to take equation alpha. So I am writing here, from equation alpha, it is I is equals to E1 by R1 plus E2 by R2 plus E3 by R3 whole divided by 1 plus R, 1 by R1 plus 1 by R2 plus 1 by R3. Now see, dear student, what we have to do. Now we have to remove this big term with present in alpha equation along with this R. So now I am dividing LHS and RHS, divide equation alpha with 1 by R1 plus 1 by R2 plus 1 by R3 in numerator and denominator. Now see, my dear student, this is our equation alpha. It is E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 plus R, 1 by R1 plus 1 by R2 plus 1 by R3. Now what we have to do, we have to divide numerator and denominator by this term, 1 by R1 plus 1 by R2 plus 1 by R3, so that this R becomes free. Then we'll compare this equation and this equation. So let's check it out. It will be I is equals to E1 by R1 plus E2 by R2 plus E3 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3 divided by 1 plus R, 1 by R1 plus 1 by R2 plus 1 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3. What we have performing here, we have to divide this equation in numerator and divide this equation with denominator. Now see, my dear student, we'll get LCM, this and this get cancelled. So what we'll get I is equals to E1 by R1 plus E2 by R2 plus E3 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3 plus R, because this and this get cancelled and LCM is 1 by R1 plus 1 by R2 plus 1 by R3. So here comes, my dear student, this is the value of current. Now see, along with R nothing is there, along with R nothing is there. Let's say this equation to be gamma. Now we'll compare equation of current present in gamma and equation of current present in beta. So I am compare equation gamma and beta. So what we'll get? We'll get E net is equals to E1 by R1 plus E2 by R2 plus E3 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3, and this is R net plus R whole divided by 1 by R1 plus 1 by R2 plus 1 by R3 plus R. Now see, this R and this R get cancelled. So what we'll get, dear student? We'll get, instead of E net, compare this thing. So E net becomes equals to, E net becomes equal to, what we'll get? E net is equals to E1 by R1 plus E2 by R2 plus E3 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3. So this is the value of, dear student, E net. Now see, 1 by R net becomes equals to 1 by R net is equals to 1 by R1 plus 1 by R2 plus 1 by R3. As we all are aware with parallel combination of resistor formula, so here comes, we have net resistance and net EMF when the batteries are connected parallel to each other. See, my dear student, the net EMF becomes equals to, E net is equals to E1 by R1 plus E2 by R2 plus E3 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3, and net resistance will be 1 by R net is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Now see, basically we are combining the batteries to increase the potential of the circuit so that current increases, because we know that potential is directly proportional to current. If any circuit potential increases, then it is but obvious that current is also be increased. When we are connecting the batteries in series combination, potential increases, but along with potential, my dear student, resistance is also increased. Hence, ultimately we'll get less current in the circuit. So we'll say, okay, connect now the battery in parallel combination. When we are connecting the batteries in parallel combination, we'll get net EMF is equals to E1 by R1 plus E2 by R2 plus E3 by R3 whole divided by 1 by R1 plus 1 by R2 plus 1 by R3. So if you are aware with mathematical equation and the previous lectures, then you will feel if the batteries are connected parallel, then EMF decreases. In series, EMF is increases, internal resistance is also increase. But when we are connecting the battery in parallel, then EMF decreasing, my dear student. But yes, along with EMF, as EMF is decreasing, in parallel combination, remember, my dear student, if resistors are connected parallel, then net resistance decreases. If resistors are connected in series, then net resistance increases. Write down in form of note, write down note, if resistors are connected, in series, if resistors are connected in series, then net resistance is increased. Net resistance is increased. And if resistors are connected in parallel, then net resistance decrease. Remember this thing, this is very important concept, my dear student. if you are connecting the resistors in series, then the net resistance of circuit increases. But the same resistors, if you are connected in parallel, then net resistance is decreasing. So we will see that in series combination of battery, net EMF is increasing, but along with net EMF, resistance is also increasing. Hence, current is decreasing. Then we will try to connect the battery in parallel combination. So when we are connecting the batteries in parallel combination, we all are aware resistance decreases. But along with resistance, see my dear student, EMF is also starts decreasing. So write down, in parallel combination of batteries, write down, in parallel combination of batteries, in parallel combination of battery, in parallel combination of battery, net EMF decreasing, net EMF decreasing along with decrease in resistance, along with decrease in resistance. So see my dear student, when we are connecting the batteries in parallel, then what we'll see that EMF is decreasing and resistance is also decreasing. So ultimately, if EMF is decreasing, then it is not possible that we'll get increased value of current. So we'll say parallel combination is also not worthful, as when we are connecting the batteries, we want to increase the potential of circuit so that current increased. We'll try series combination. In series combination, EMF is increased so that current is increased, but along with EMF, internal resistance also be increased, hence current decrease. Then we'll try parallel combination of battery. So when we are connecting the batteries in parallel, what we'll see EMF is decreasing, my dear student. So if EMF is decreasing, along with decrease, no doubt resistance is decreasing, but along with decreased resistance, EMF is also decreasing, which cannot give you the maximum current, or we can say which cannot increase the current in circuit, because in parallel combination EMF is also decreasing. So if EMF directly is decreasing, then it is but obvious that current cannot increase. So what we'll see in series, again worthful, not worthful to increase the current. If we are connecting the batteries in parallel, again it is not worthful, because due to parallel combination, current, EMF is decreasing, resistance is decreasing, but as EMF is decreasing, so what we'll see current is decreasing. I hope you all understand the basic structure of combination of battery. So my dear student, what we'll do now, because series cannot capable to increase the current due to increase in resistance in series combination. Similarly, if we'll connect the battery in parallel combination, what we'll see, resistance is decreasing, but along with decrease in resistance, EMF is also decreasing. So again, in parallel combination, current is not increased, in series combination, current is not increased. So what we'll do, we'll conclude that all the devices which are operating with the help of battery, I am repeating once again, all the devices which are operating with the help of battery is always run in mixed combination. Write down in form of note, dear student, all the devices, write down, all the devices which is operated, all the devices which is operated with the help of battery, all the devices which is operated with the help of battery is always in mixed combination, Mixed means series as well as parallel, always in mixed combination. Put a bracket and write inside the bracket, that is series combination and parallel combination. Series combination and parallel combination. Now bracket close, write down next point. If the batteries are connected in series, due to series combination EMF increases. Due to series combination EMF increases. Due to series combination EMF increases, and due to parallel combination, and due to parallel combination, and due to parallel combination resistance decreases, and due to parallel combination resistance decreases, and due to parallel combination resistance decreases. So conclusion is, my dear student, that any device which is operated with the help of battery is always in mixed combination. Mixed means series as well as parallel. Why series and parallel? Because we know that individual composition cannot increase the value of current. What we'll see, as in series EMF is increasing, but along with EMF resistance is also increasing, hence current is decreasing. In parallel combination EMF is decreasing, resistance is also decreasing, but if EMF is decreasing, it means current cannot be increased. So what we'll conclude? We'll conclude all the devices which are operated with the help of battery is always, remember my dear student, is in mixed combination, operated in mixed combination. Mixed means series as well as parallel. Series combination decreases the potential, series combination increases the potential of circuit, and parallel combination decreases the resistance of circuit. So this is how we have to understand battery combination. Remember, one is series combination and other is parallel combination, and all the devices which are operated with the help of battery is always operated in mixed combination, because independent combination is not effective. Independent combination, that is either only series, only parallel, is not effective. That's why we'll take a midway path. We will run all the devices which are with the help of battery is always in mixed combination. So I hope you all understand the battery, how to find the potential of battery, how to combine the batteries in series and in parallel. So thank you so much, my dear student. Today in next class we'll discuss some more topics. Now we are very soon to complete this chapter. Next portion of this chapter is electrical instrument. So from next class we'll discuss electrical instrument. Till then, thank you so much, my dear students. Stay safe, stay happy, stay at your home and study hard. Take care.